and we start with doing an exercise. And in particular, remember the first lecture we were talking about class stack to implement a very simple stack. And today we are going to work again on this stack class, and in particular we are going to see, for example, how to implement a way to copy a stack. So the idea is, suppose that you have a stack and you fill it with things, and then after a while you want to copy it. Okay. So here, for example, okay, this was the sample we did the last time, and we were trying to catch errors. Today, instead, we are going to do something a little bit different. So, for example, suppose we are going to use this. We are going to put 10 elements in the stack. I'm going to put 10 elements in the stack, and then I want to create another stack as a copy of the first one. And suppose also I'm going to write a function for printing all the elements of the stack. So let's define a print here. So we can look at the content, and I'm going to implement this print in the CPP file. So what we have is S is the let's say the element, the first free element in the stack. Okay. So this prints position and how much is it. Okay. And I'm going to write also first prints how many elements in the stack, and then it prints on every single line the content of this stack. Okay. I'm going to write also a little makefile for simplifying the compilation. So here I have a little makefile. I'm going to specify the flags for the C++. The flags for the linker. I don't have a specific flag for the linker, the CPP command, and the linker command. These are the suffixes .o and .cpp. The structure is one of the XX I was going to compile, and the other one is going to be called stack main. Okay, and let's do sorry. So here I list the sources for the stack, and I'm going to see that the objects are just the same thing but with .o instead of .cpp. I'm going to compile everything with this, and I'm going to link everything by using, sorry, I'm going to use to link everything by using this. Okay, so basically the idea is that this is the command for linking. Okay, this is the command for compiling, and here I'm just listing all the sources for the stack and all the sources for the destructor, and these are the two things I'm going to compile. So I do make, and this will try to compile the stack. I have an error in stack. Basically, cout has not been declared because I forgot to specify the standard library. So I'm going to change that, of course. So this cout cannot be found because I forgot to specify. Oh no, it's here. I forgot to include the IO stream. Okay, so now it should be okay because cout is defined in this header file. I made an error probably because let's see what I did as an error in the makefile. Oh yes, I forgot, sorry. Okay, now it compiles and I execute with stack main, and I have immediately a core dump because I made some error. And let's see what is the error. And the error is probably in this copy constructor. Can you imagine what is going on here? So if I don't do the copy constructor, so if I do this, I see S printed and nothing bad happens. Everything is okay. See? As soon as I activate this, I have a big error. No, sorry, I have to compile. Okay, so it looks like the problem is the fact that I'm using the copy constructor. And let's see what happens. So I run the program. The first stack has been printed, and then it says error in stack main, double free or corruption. That's the backtrace, and this is the memory map. Very difficult to understand. So anybody has any idea? So clearly the problem is here. And as you can see, I don't specify any copy constructor. So this means that when I don't specify any copy constructor, then the default one is going to be called. And what's the default one doing? The default one is doing a bitwise copy. So it's copying all the elements bit by bit. And what are the elements inside stack?
There is a pointer.
There is a pointer and two integers. So it's copying the pointer and copying the integers. Now, this means that the first constructor, the one of S, is actually creating the memory. The copy constructor is just copying the pointer, but not the memory. Then the destructor of S will delete the memory, and the second destructor of S2 will also try to delete the same memory. So this is a double free. So I'm freeing the same memory twice, and of course that's a memory corruption. So the problem here is that the copy is not correct because I'm not copying the stack, I'm just copying the pointer. This is called a shallow copy because I'm not copying the object with all its content, but I'm just copying the external shell, the pointer. If I want to copy the object, what I have to do is to implement what is called a deep copy. And in particular, I have to write, I'm forced to write a copy constructor. So this is one example of why the copy constructor is needed. To change the standard behavior, which is a shallow copy, and to implement the deep copy, so copying all the elements, including the memory pointed by the pointers. So this is called deep copy. So let's write this. So I want to copy a stack. So what I have to do is to initialize the array by passing what? Okay. Oh, the other max size. Sorry, I cannot use S because S is using as a local variable. So I'm going to use other. So array is initialized to new memory, and the size of this memory must be the same as the size of the other memory. Okay? Then m size must be equal to the other m size, and S I initialize for the moment to 0. The second thing I have to do is to copy all the elements. So for example, I can write a for cycle. Actually, I can do that directly here. This will copy all the elements, and then I just initialize S. Of course, I can also initialize here. So yes, let's do like this. Okay, so allocating new memory, copying all the other elements, and then copy all the memory. Okay, so now hopefully it will work. I forgot to specify int here. It's called m size, right?
Yeah. And in the copy constructor.
Oh yes, sorry. Yeah. Okay, and then I run, and everything goes okay. So no more memory corruption anywhere. Okay, so deep copy instead of shallow copy. Another thing we would like to do is, for example, to access any element inside the array by using the operator with the square parentheses. Let's see how to write that. So of course this will return an int, and of course it will take an integer as an index. Okay, and of course this integer has to be proper, so this may throw an exception. Okay, so if I is less than 0 or I is greater than m sides, then true. Okay, and otherwise I return okay. And so we are going to change the way we write this print by using okay, no, so for a moment let's leave it like it is. Okay, so in the main, for example, we may want to see out the, I don't know, third element. Okay, remember we count from 0, so the third element is the one with index 2. Okay, compilation, and then third element. Okay, so this is about the stack. What else? Okay, let's suppose now that we want to have a stack of different kind of elements. So not only integers, but something a little bit different. And so we are going to use one specific class and use a stack of that class. Okay, and let's see what this means for us.
Excuse me.
Yeah.
A question. Why to check if the index is more than the max size instead the actual size?
Oh yes, you are right. I mean, this is something. This is just a design decision. So yes, yes. Otherwise, we'll just so max size, of course, is because we don't want to cause memory corruption. But of course, that should be like that. Oh, I forgot to say that in C++ you can use this kind of keyword for Boolean operators, or, and so on. Okay, so it's actually a little bit easier to read.
Or is operator is I can redefine it. No.
No, so you cannot redefine the operators for primitive types.
Okay.
For example, you cannot redefine the sum of integers. Okay, and or if I remember well, is only for booleans, and is cannot be used for non-booleans. Instead, you can redefine the hold operator. So this one.
Yeah. Okay.
So you can write this.
Okay.
Oh, by the way, so I just forgot. So suppose instead that we want to eliminate. So I'm going to do something a little bit different here. Suppose that instead of specifying a max size in the constructor, we want the array to be dynamically resized every time I push a new element and there is no space. Okay? So this max size now becomes a dynamic variable, not a constant, and we want to modify it as soon as, so basically the stack should be able to enlarge itself when we do push. Okay, so let's try to modify it this way. So first of all, we eliminate the need for specifying a parameter here. Okay, and we suppose that initially m size will be equal to 2, so only 2 elements. So we eliminate this, and n size is initialized to 2, and initially the array is just 2 elements. Okay, the rest remains the same. What we have to do is to modify this push. Okay, so if array is less than m size, so if s is less than m size, we just do the same. Otherwise, instead of throwing here, we have to enlarge. Okay, so to enlarge, we will do like this. First, I define another array which is going to take double the size of the previous one. Okay. Then I'm going to copy everything. Okay. Then I'm going to delete the old array, and then the new array, the array takes the address stored in new array. Okay. And of course, I have to modify m size. And now I can insert. So actually, I'm going to do this before. So I'm going to change this radically. So after this code, the array has been enlarged, and so I can finally insert. So let's analyze again. If S is equal to m size, it means the array is full. So I create new memory. I copy all the elements from the old array to the new array. I delete the old array. I just assign the pointer. I double size, and then I can finally do the assignment. Okay? So this should work fine, and let's see if our previous main works well. So I don't specify anything anymore here, and it should work. I forget. I wrote in a wrong way because I never remember how to write it. Oh, it's okay. So basically, I forgot. Never remember this syntax. I always need to look on the internet for it. Okay, now it works. Okay, so it just the same output as before, but we don't need to specify the size because the size is enlarged automatically. Okay. We can make something a little bit better here, and in particular, for example, instead of writing this cycle, we can use some of the standard template library algorithms. Let's see how to do that. Here is not really necessary, but in general, it's much better to use standard template algorithms for everything because they are more general and easier to generalize. So copy is what? Okay, so this is a site, C++ reference, c++.com, that provides you reference with many of the C++ standard template library. And in this either file algorithm, you will find a lot of very simple functions that can help you in doing simple things. One of these is copy. And the nice thing about copy is it doesn't work only on arrays, but works on any kind of sequence, any kind of container. So for example, all containers of the standard template library work with copy, okay, because it uses the template mechanism. So basically what we have to specify is where to start, where to finish, and the first element in which to copy. So basically, it's easier to write than to explain. Here, we start from other array. Okay, we finish at other array plus s, and we copy into array. Okay. So this is exactly the same thing as before, but written using the copy standard template library function. And again, this works on any kind of things. So in the future, if instead of using an array, you want to use, for example, a vector, then this is going to work. Of course, we can do the same here. Okay, let's try if this is true. Yes, I mean, probably. We didn't do the other try, but we are pretty sure that it should work. Okay, so copy, it's the standard template library algorithm for copying things. Okay. We will come back to this implementation much later, and for integer, it's okay. I mean, this algorithm works quite fine. But when we are going to move to more complicated implementation by using templates, you will see that there are a lot of very subtle problems can arise in this kind of code, and so actually we are going to use a completely different approach to implement a stack. Okay, so before concluding this lecture, we just go back to our slides and we talk a little bit about type conversion. Type conversion means we have one thing of one type and we want to transform into a different object of another type. Okay? And this conversion can be done in many different ways. And one way of doing that is by using a constructor. So basically, when you define a constructor that takes one single argument, and this single argument is an object or a constant reference to another type, that constructor can be used by a compiler for performing an automatic type conversion. For example, suppose you have class 1, and this class 1 contains nothing, it's just as an example. And then you have class 2, which takes in the constructor a reference to an object of type const1. And then suppose you have a function which takes as an argument an object of type 2. Be careful, an object, not a reference, an object. Okay? Then in the main you have an object of type 1 and you call f1. Well, what the compiler is going to do now is looking for a function f which takes 1. Doesn't find it. It finds instead a function f which takes a 2. So now the compiler tries to automatically convert 1 into 2. And it finds this constructor and says, oh, I have a way to obtain a 2 from 1. So I'm going to do that. It builds a temporary object of type 2 by passing 1 and passes this temporary object to f. So this is how to do automatic conversion. Okay? Let's make another example. Suppose you have a class AA which has a constructor which takes an integer. Okay, very simple and also very common. And suppose you have a function which takes an object of type AA by copy. Then in the main you call fun5. Well, what happens is that there is no function which takes an integer as an argument, but you have a function which takes this class as an argument. So the compiler takes this 5, converts that into an object of type AA, a temporary object. This temporary object is passed to this function and copied into X, and then X is printed. And so if you actually compile and execute this code, what you see is cout 5 on the screen. This can be some trouble, because sometimes it's just an error. Sometimes you want an object of class AA, not just an automatic conversion. But the user just writes something like this, because it's bad typing, I don't know, whatever. And the compiler doesn't complain. It actually does an automatic conversion, and you are in trouble because you didn't want that. So to prevent this kind of implicit conversion, we can use the keyword explicit. So basically in front of the constructor you write explicit. And this means that the compiler is not allowed to implicitly convert 5 into an object of type AA. Okay, that's not allowed. So for example, in the main now, if you call fun of 5, this will give you an error. However, if you call fun AA5, then this is okay, because you explicitly converted the 5 into AA. Okay? Of course, the first one is probably an error. The second one is not an error. You want to do that, and so it's okay.
Well,
yeah.
What if we also had a constructor of A which takes a float we have two constructors, one which takes an int and one which takes a float.
Yeah.
When we call fun5, is it legal?
Yes, it's legal, and it uses the integer because it's the closest one.
Okay.
If you want to call the other one, you have to specify that 5 is a float. So you either write 5f or you write 5.0.
Okay.
But never do that. Never try the do function which just differs between int and float. Okay?
Okay.
Okay, so we have seen time conversion using that. And another, of course, if fun takes a constant reference, then of course there is no way to convert. I mean, this only works if it's actually asking for an object. A very special kind of operator is the an operator which has the same name of the type on which you want to convert. So suppose you want to convert 4 into 3, and 3 has a constructor which takes 2 arguments. Okay? And you want to convert another class 4 into 3, but you cannot modify 3. So you cannot write a constructor in 3 that takes a constant reference to 4. Okay? So how can you do? Well, what you can do is to write one very specific type of operator into 4, which has the same name as the class to which you want to convert. So here you will write operator 3 const returns 3x, okay, which x is an integer, of course. So now you have a function g which takes a 3, and in the main you have an object of type 4, and you pass 4 to g, and everything goes okay. Why? Because this 4 is converted into 3 by using this strange operator. Okay? And so this is the second way of converting it. You will probably not need too much to use these kind of things, but it's just to let you know, in case you find in some strange code, that you also have this kind of operator. And also remember this explicit, because it can save you from some very stupid error along the code, because catching this kind of errors is very difficult. So if you remember, please use explicit when you have a constructor which takes just an integer or a very, let's say, basic kind of type of data. Okay, so this is everything for today. So let's have just a quick look at what we are going to study next week. So next week we will continue with some of the basic things. In particular, I'm going to discuss inheritance. So we are going to see the basics of inheritance and virtual function, virtual destruction, pure virtual function, and things like that, and how this interacts with all that we have seen today. So basically, for example, copying and converting and conversions and things like that. Okay. Also, next week, probably, I don't know exactly when, I'm going to give you the first assignment. So next week, expect the first one. So the lecture is going to be on Wednesday, right? Yes. Wednesday at 11. Okay, that's it for today. Thank you. If you have any other question.
Excuse me.
Yep.
In the last slide that you present.
Yes.
In the constructor of 3, what is the next the second argument, int equal to 0?
Okay. The constructor of 3 is taking in 2 arguments, but both of them are default.
Yeah, but there is int equal to 0. I mean, no any name to the.
Sorry, I didn't understand the last word.
I mean, there is just int without any name to the variable equal to 0. Is it correct, or maybe there is a mistake?
Yes, yeah, there is a mistake probably, yes. Sorry,
Okay.
this is just a typo in my slides.
Okay.
Thank you for highlighting it. So this should be, I don't know, J or something like that, okay?
Okay. Thank you.
Okay. Thank you. So see you on next Wednesday. Bye-bye.
Bye.